Going on now to topic 1.2 of chapter 1. We're going to deal with symbols and sets of numbers. Now, each of these mini lectures are set up like this page, in which we have the learning objectives. Then there will be a few examples, and then there are some teaching notes that I've left there because often these are the things students might have difficulty with. So in reading them, you can see whether or not you had difficulty and whether that was met either through the lecture or the presentation or the work you did in Math Zone. And then another thing that will be on every page in your booklet, whether you noticed it yet or not, is down at the bottom. We will have the answers to all of the examples. So we'll be working them, but keeping in mind the answers are right there. And that will be for every lesson we do. There are a few in which there are graphs that won't fit on the page, so those aren't there, but we'll be doing those in class when we get to chapter 3. So let's take a look at what we're to look at in this section. Use a number line to order numbers. Translate sentences into mathematical statements. Identify natural numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. And then find the absolute value of a real number. So we're looking here at absolute value. Now, to get us set up, let's take a look at a number line. We'll use this as a typical number line. And by the way, when I went to elementary school and high school even, they weren't talking about the number line. But over the years, this is a strong concept included in all math courses, a number line. So it's a horizontal line in which you designate, sort of toward the middle, the number 0. And you say, this is 0. Well, to the right of it, what will this number be? Well, 1, and then 2, 3, 4. And now what we're going to do is start to develop some definitions of sets of numbers. And since you have this booklet, any of the stuff I'm putting here, you can put in your booklet as well. These are the notes. And keep in mind, you can also look at the textbook. You should look at the textbook. And you'll see similar material there, but presented a little differently. So, for natural numbers, the set of natural numbers, we're thinking the numbers 1. That's the first number, the first natural number. 2, 3, 4. And what I've done is I've made a graph of the natural number set, and there is 5. I should put that there too. And then I'm going to use what is called an arrow darkened to indicate that this pattern continues on until infinity. This is the symbol for infinity. And to indicate this pattern is continuing, You've seen this before where we use just 3 dots. The 3 dots are called an ellipsis, which indicates the pattern continues. And this set of numbers up to positive infinity are the natural numbers. Now another set of numbers are the whole numbers. Now the whole numbers include all the natural numbers, but we also add 0 to it. So now I have drawn the graph of the set of numbers called whole numbers. Now notice on this side we haven't done anything with it yet, but actually on this side where you have a positive 1, there is an opposite to positive 1 on the other side of 0, to the left of 0, and that's a negative 1. And we continue, negative 2, negative 3, negative 4, and these, when we add them, the whole numbers and their opposites, make up the set of numbers called integers. And to graph them, I just put dots on these. Now, are there other numbers on the number line? And you see there are spaces between them. So for instance, right here, and let me change color, we have a number 1/2. And right there is the number 1/3. And over here is the number 3/2. Well, these that come between the integers, they're usually referred to as fractions. And fractions that occur between the integers, along with all of the integers as well, make up the next group of numbers, the next set of numbers, called rational numbers. But there are some qualifications to this. To be considered a rational number, we have to have, when we convert a number, let's say like 1/2, to a decimal fraction, and the number 1/3 to a decimal fraction, and these threes repeat. And to indicate that it repeats, we put a little repeating bar above the 3. But here we see the fraction terminates, that is, it doesn't continue to go on. And here the fraction repeats. So the fractions between the integers, and including the integers, that repeat or terminate, these make up the rational numbers. So everything on here now is a rational number. Some of them are integers, some of them are whole numbers, some of them are natural numbers. Now, are there other numbers on here? For instance, right about here, and I'll change color again, let me use green. Right about there, there is a number called the square root of 2. Now, the square root of 2, if you evaluate that, that is 1.414, and it continues to go on, not in a repeating pattern, and it doesn't terminate. This qualifies it for a special set of numbers that are on the number line, but do not repeat in a pattern nor terminate. These numbers are called the irrational numbers. And others are like the square root of 8, which is right about there. Because if you had the square root of 9, that would be 3, and that would be right there. And this is the square root of 15 is about there. Square root of 16 would be 4. Now, if a number under the radical sign is a perfect square, like the square root of 16, then this just equals 4. Remember, 4 is a natural number, it's a whole number, it's an integer, and it's rational, because when we do the operation, the square root of it, it becomes one of these. Perfect squares under the radical sign. And another famous one, right over here, is pi, which is irrational, which is 3.14, and that continues, again, without repeating a pattern or terminating. Okay, now the number line is quite useful to illustrate all of these things. And finally, all of the numbers that we've talked about on the number line are what we call real numbers. Okay? So, the set of numbers we work with in much of the math you're going to cover is the real number set, composed of all these subsets. And they'll be asking you questions about them. Now, another thing we're asked to do here is to compare numbers as they appear on the number line. Well, let me say, while this is still here, any number to the left of something is going to be less than something to its right. So, when we see, and let's just go over these, this is the less than, this is the greater than, and of course this is equal. Okay? We want to place these symbols into our examples. So 2 is there, 8 is way over there, so 2 is less than 8. Remember, all these answers are down below as well. Now 41 is way out there, and 14 is to its left. So 41 is greater. Now here is a positive number. There is its opposite on the other side. So any positive number is greater than any negative number. Now, when you get something like this is a little tricky because you need to know your fractions a little bit. And when we compare fractions, we have to compare their denominators as well, and often making them equivalent fractions. Now, we are allowed to multiply any fraction by 1, and it doesn't change its value. But we can choose the one that we're going to use. Suppose we say our 1 is in the form of 3 over 3. This is 1. So 3 times 3 is 9. 7 times 3 is 21. So what do we have here? Well, we have 9 21s and 9 21s, or 21st, I should say. And what are these? These are equal. Now, they didn't look like they were the same, but when we made them equivalent fractions by multiplying it by a 1 in the form of a number that is the same on top and the bottom, so that we make our denominator the 21, that was the key to what we do here. We had to multiply this by a 3 to make it 21. Then we can compare them and we see they're equal. And here we're asked to determine whether each statement is true or false. And again, practice reading this. You could read it silently while I read it aloud. 15 is less than or equal to 20. Well, if one part of this is true, 15 is less than 20, so this is true. Now here we have a decimal. So here it's 3.2, this is 3.0. So this is not greater and it's not equal. So this is going to be false. This side, if it was this way, it'd have been true, but it wasn't that way. Now, another use of the equal sign when we have a slash through it, that's read is not equal. So when we divide this, and notice again, or we can multiply this by 2 over 2, we get 14 over 18. And this gives us 14 over 18. And they're saying that this combination, as it originally appears, is not true. It does not equal. Well, in fact, it does equal once we convert this fraction. So that is false because it is equal. And then here we have 6 sevenths. Now again, 6 sevenths, if we want to make our denominator of 14 of the 7, we're going to multiply it by a 1 in the form of 2 over 2, which gives us 12 fourteenths. So we can now put that there. Is 12 fourteenths greater or equal to 11 fourteenths? Is one part of this true? Yes. So that one is true. Okay, now again, hopefully you're taking some notes. You're writing in your booklet. Remember, there's a free page on the other side. Put any reference you want there. Show any detail. Show that you might need help. For instance, put a question mark. Put something in the margin. This is your booklet to be used as needed. Now, in this section, what we'll be doing is to translate each sentence into a mathematical statement. Okay, let's read it closely. Negative 11, so we can just do that right here. Negative 11 is less than, or equal to negative 4. Okay, that's pretty straightforward. 14 is, and is translates into an equal sign. But they're saying is greater, so not an equal sign then. That's why it's important to read the whole thing. Is greater, let's get the greater symbol here, is greater than 1. All right, that's better. Okay, that was easy here. All right, now what they're asking us to do, tell which set each number belongs to. A natural number, we'll use n for that. Whole numbers, let's use a w. Integers, we're going to just use the letter I. Rational numbers, well, we have irrational. We'll use IR for this. And real, we're going to use a capital R for real numbers. There you go. Now, as we look at these numbers, all of them are real numbers because they're all on the number line. But 5 is a natural number. It's a whole number. It's an integer. It's rational. And it's real. So we can put the R there. Now, negative 3, is it natural? No. Is it a whole number? No. But it is an integer, it is rational, and it is real. Now, 8/3, is it a whole number, a natural number first? No. Is it a whole number? No. Is it an integer? No. But it is rational, and it is real. Now, the square root of 5, it's not natural, it's not whole, it's not an integer, it's not rational, it's irrational, but it is a real number. Now, 0, is it a natural number? No. Is it a whole number? Yes. Is it an integer? Yes. Is it rational? Yes. And is it real? Yes. Now, a number can't be irrational and rational. So keep that in mind. Okay, now for this last part, I'm going to make another number line for you. Now, on this number line, I've put -2 and a 2 that I'm going to be featuring here. Now, absolute value, by definition, is the distance a number is from 0. And to determine this, we use positive numbers. Because if we count the number of units, -2 is from 0. There's one number, that's positive. There's a number, that's positive. It is 2 units from 0. So the absolute value is the distance that something is from 0. So if it's negative, the distance is going to be a positive distance of 2, and 2 itself is a positive distance of 2 from 0. So whenever we see the absolute value sign of any number, it will always be its positive value. So we say absolute value sign is to do some operation. Find the distance this is from 0. Well, its absolute value will always be positive. That makes this a lot easier to do. So this is going to be 6.2. This is going to be 14. This is going to be 2/9. This is going to be 0.03. And 0, in a sense, is just 0. Okay? Now, it gets a little tricky, and you'll see these. If they put, let's say, a negative sign in front of the absolute sign, so it comes out of here as a positive value, which it is already, but then we apply the negative sign, just like this one. It comes out of here as a positive value, then we apply the negative sign. Okay? So keep that in mind. You have to read them carefully. And good luck on your first practice and quiz me on section 1.2. Remember, all of the answers are down below.